Hello everyone, my name is Dr. Arif and I will be presenting our community research project Fuel Oil from Plastic Waste using the Pyrolysis method. Our team consisted of our 4 team members as presented here on the slide. The agenda for today's presentation is I will present you first introduction, background to the problem, and then the method, then research results, and then the conclusions. Let me first present you the introduction of the problem. As we are all aware, plastic waste presents serious dangers to the environment and human health. Its long-lasting nature and difficulty in decomposing makes it one of the most difficult and detrimental environmental pollutants. When not managed properly, plastic waste can pollute and have a negative impact on wildlife and ecosystem balance. Innovations in recycling, reducing the use of single-use plastics, and developing environmentally friendly management methods provide a hope for reducing the negative impact of plastic waste. One of the waste processing efforts is to convert plastic waste into oil using the pyrolysis method. Pyrolysis is the process of decomposition of material at very high temperatures in the absence of air or with very limited air. So based on the background, the following problems are addressed. How to process plastic waste to fuel oil through pyrolysis method so as to reduce plastic waste from accumulating so that it cannot harm the environment. The concept of fuel from plastic waste emerged as an interesting solution. The process converting plastic waste into liquid fuels or synthetic fuels has been a concern because it can reduce the amount of plastic waste polluting the environment while creating alternatives to fossil fuel. However, there are a number of challenges in the implementation of this technology. First, the efficiency of the process of converting plastic waste into fuel still needs to be improved in order to compete with fossil fuels in terms of cost and performance. Secondly, it is necessary to consider the environmental impact of such conversion processes, including greenhouse gas emissions and waste resulting from the process. Nonetheless, the development of fuels from plastic waste has great potential to address two major problems at once: environmentally damaging plastic waste and dependence on fossil fuel. With continued research and innovation, this technology could be an important step on the road to a cleaner and more sustainable environment. Based on this background, the important question is to how to process plastic waste to fuel oil through pyrolysis processes so as to reduce plastic waste from accumulating so that it cannot harm the environment. In order to achieve this goal, we did study several research papers which have been addressing this problem, and we come up with a method which has been shown here.
The initial stage is the preparation of pyrolysis material that is plastic from bottles of mineral water. This is a type of PET polyethylene plastic that is abundant around us and is easy to recycle. The next step is to insert pyrolysis material into the reactor. Next stage is installation of reactor. Next stage is to run a pyrolysis device that works at 500 to 700 degrees Celsius for about 4 hours to be able to produce fuel oil. After approximately 4 hours, 270 milliliters of oil is produced from 350 grams of plastic, so that in 1 kilogram of plastic will be produced as much as 771 milliliters of oil.
So I will present you now the results and discussion of our research. It is well known that at a temperature of 100 degrees Celsius, polypropylene and HDPE plastics do not produce oil. This is because plastics do not undergo the melting phase or melting point of either PP or HDPE plastics, because their melting points are 168 degree and 138 degrees C for PP and HDPE plastics. So that in order to produce oil, the plastics should be heated well above its melting point so that it can undergo a decomposition process. Decomposition is a state in which the plastic will easily flow and the structure will undergo decomposition. As the properties of PP and HDPE plastics are, they are strong, hard, semi-flexible, and the wax surface is still the same as the state after heating, where the residue is difficult to clean and the surface of the residue is waxy and hollow on HDPE plastics. Now this graph presented here, it shows as we increase the temperature of the pyrolysis, the amount of fuel produced from the PP and HDPE plastic increases. So it shows a linear relationship, whereas at 400 degrees Celsius, we have more fuel from PP plastics than HDPE plastic. Here another curve is shown, or graph is shown, which shows the pyrolysis time versus the temperature. Pyrolysis time is the length of time the pyrolysis process takes in processing plastic waste into pyrolysis oil. The duration of the pyrolysis process is calculated using a stopwatch from the start of heating the reactor containing plastic waste until the end of the pyrolysis process is marked by no gas is produced. The graph shows that the pyrolysis time is getting faster with each increase in temperature. The fastest time for PP plastic is at 450 degrees Celsius with a time of 300 minutes, while the fastest time for HDPE plastic is at 330 minutes. So, in conclusion, the reactor temperature, we could conclude that the reactor temperature influences the volume of oil produced and the time of pyrolysis. Because the higher the temperature, the more oil is produced, and the time and the pyrolysis time will end more quickly. So, in conclusion, in simple words, we can say that the higher temperature would result beneficially for the pyrolysis process. But on the other hand, producing higher temperature would require more energy. Thank you very much for listening, and please provide your feedback on our research. Thank you so much.